Okay, welcome back to another episode of Simplifying Code. This is going to be another case where I'm going to take some student code, and admittedly, this is some code from like a week or so ago, so it's quite likely this student in question has changed it since then, but that's when I looked at it, and I'm going to use it to illustrate some ideas. So as you can see on the screen, this is an ultimate Tic Tac Toe game. If you're not familiar, it's basically Tic Tac Toe squared or something, where you play on these small boards, and then initially you can go anywhere. First player plays. Now whatever small square they played in controls what board the next player has to play on. So now O has to play somewhere in this top left board because of this going here, and so now if they played in the center, then that sends X back to the center board, who can play here, and now O can play here and block that. And so the goal is to win the small boards, and that if you win a small board, then that's like makes a move in the big game, and then the goal is to get 3 in a row on the big board. So that's what the game looks like, and now we'll take a look at the code, which I have over here, and here. Save those. Okay. And I don't really need the style sheet. Okay. So, and this code I have tidied up a very little bit just to take some stuff out that we just was cluttering things up. So we're going to talk about it. Okay. So and the thing I want to emphasize in this code is that this code grew by accretion, where they started with the original Tic Tac Toe and started trying to turn it into Super Tic Tac Toe in a way that is mostly on track, but also they've got lost a little bit in the complexity, as we can in fact see that like one of the things that's supposed to happen is if I play here, next player should only be allowed to play over here, yet doesn't enforce that rule and then lets me play anywhere. And that may be due to a simple bug, or maybe due to a complex bug. I guess we'll see when we look at the code. But so there's at least something wrong here. And I think part of the problem is that the code is just a little bit hard to understand for the student who's working on it. And so I'm going to show some ways that we might be able to simplify that. And the main one is just to be really super clear about what different things are. And this place I'm going to start maybe is just with some names and even some concepts, right? So like in normal tic-tac-toe, we had, a lot of us had, a board. I recommended that you make an array that just holds the marks, and you use that to do all of your logic of figuring out whether there's 3 in a row or not, or whatever. And then also we had an array of the cells so that, actually for tic-tac-toe, it wasn't even that important. You could get away with just having 1 or whatever, but it was where we started to have like an array, and then the cells were how you actually showed things on the screen, and you had to like keep them lined up. This case, it gets even more complicated because back on our board, there's similar setup where there's cells that we can click on to make moves. And then those cells are part of a bigger cell. And in fact, we can inspect this page and sort of see what the structure is. So there's the board is this whole big thing, and it has 9 divs inside it. So those are like the big cells of the board, but then each of those itself is made up of 9 cells. And if we look at the style, we'll see that they're both a grid display, right? This is a 3x3 grid, and then this is also a 3x3 grid, and there's some colors whatnot to make it look nice. So conceptually, I'll even make some notes here. I'm going to make them up at the top here. So conceptually, we have like big cells contain small boards, small cells, what we actually click on. Because when you move, you're still picking a small cell. There's just more complex logic about whether it's a legal move. Click on and put marks in. Okay. And then, and if we look at this code, we see one of the first things is this function, empty board. And I'm going to actually move that up to the front. It's a good idea to have all your function definitions come first. So I'm going to sort of systematically do that. So empty board is making what it says, an empty board. And that's because in this game, because there's actually 10 Tic Tac Toe games going on. There's the 9 small boards, and then there's the one big game. So there's going to be 10 different arrays that each represent the state of one game. One that gets updated when we click on the small squares, and the other one that gets updated by a little bit different mechanism when we win one of the small boards. Then that puts a mark into the array that represents the big board. But at some level, they're the same. It doesn't matter how the marks got put into the array. We can still use the same function to test whether like the game has been won or whatnot. Okay, and so then there's some variables. This is getting everything set up. And so I want to first go through and just make sure these names are all good, so we're clear about what we're talking about. And so up here, my list of concepts, I'm going to say a board is a 3x3 array containing marks X, O, or, right? And then, and we'll say these cells are going to be divs in the page. And we can even just say like all the cells are divs in the page, and then the big cells contain small boards, and the small cells contain things we click on, and so forth. So we sort of have cells, and then we have a board, and marks are just strings. Okay, and so let's keep going, looking at these variables. Okay, so move, this is the move counter, just like a normal tic-tac-toe, which mostly we just use to keep track of what is it, an even or an odd move, whose turn is it. Game over, this is presumably now like the whole game is not over until someone has won on the big board or the big board is tied. So that's what that means, though we also have a notion of like the small boards can be over when someone wins or ties one of those boards, but it's a little bit, as we'll see, maybe a little more complicated than the simple tic-tac-toe, because it's not just when there's been 9 moves made. All right, and then we have a big board, and that is well named because it is in fact a 3x3 array, which we're going to use to store the marks about the state of the big game. And next board is presumably here for the purpose that we talked about. I'm going to move these let variables up together. These are the things that change. It is the board that we have to play on. And we'll have a couple choices about how to refer to, like what value should it be. But for the moment, I'm going to say because it's called a board, and we said boards are 3x3 arrays, I think it's going to be one of these arrays. And if it's not, maybe we'll either change its name or change what we store in it. Okay, now inner board, this looks like we can see this is filled in some kind of loop. So this is like, now that's actually a confusing name to me because this is an array, so it's going to contain a bunch of things. And if we see, this is kind of following the pattern of every row we push an empty array onto this array, which makes it a 2D array. And then inside here, somewhere, I assume we're pushing something into board row, which is an inner board, which is actually an empty board. So this is actually especially confusing because these variables are all named the same thing, but they're actually different. This is a new variable compared to that one. So the very first thing I would do is I'm going to rename this symbol to inner boards plural. Arrays usually have plural names because they contain multiple things. And so that at least helps us distinguish between inner boards, the array, and inner board, which is one particular board that we're going to stick in inner boards. And I'm going to actually go, I had this big and small. Let's call these small boards, just to, I don't know, that's how I tend to think of them. All right, there's big and there's small. And then inner board cells looks like, at least it's plural, and that's like another, looks like it's going to be a 2D array that's going to contain the actual cells. Oh, and it looks like we're assigning the cell to next board rather than a board. But let's keep everything parallel. So we've got small boards and small cells. We could take a page out of one of my earlier videos and combine those into one array of objects rather than two parallel arrays, but let's not get ahead of ourselves. And then inner board game over is, looks like, is an array of Booleans. It's going to, looks like it's being used to keep track of what I mentioned before, that we get it, like the individual small boards can be over, and we might want to keep track of that because like you can't move in a board once it's over. That's one of the rules. So that's also starting to suggest maybe it would be nice to have, like I said, one array with an object where we could have like the board and the cell and the game over. But like I said, let's not get ahead of ourselves. We're just going to bring this into our naming convention. So small game overs, which is a little bit of a funny name, but it's kind of capturing it's the small things and it's whether they're game over, and there's plural because there's 9 of them. So we've got these sort of 9 parallel arrays. This one is filled in advance. These are going to get filled in as we go. Okay. And this is fine. So the main meat of this code is these actually several levels of nested loops. We got a loop over big R, which I guess stands for big row. And then big C is the big columns. So that's a 3x3 loop. And then inside there is kind of our old 3x3 R and C loops that's building up one each time through here. We're building up one small board, though the click handler is going to be a little more complicated because the game is more complicated. So just in the interest, I think I showed you this pattern of making a variable and then pushing it on so then we could refer to it later. But I think actually an even simpler way to write this is to not have this variable. We're just going to push the empty array onto small boards. So this is like the row in our small boards array. And then down here, when we want to refer to that particular row, we can just say small boards big R. I don't know, this is a little more complicated, but then we don't have this extra variable to keep track of. And we can do the same thing here. So we're basically pushing the rows onto our small boards and our small cells, 2D arrays, and then we're going to replace row with small cells, big R. And that at least makes it a little more clear. Like it's very clear that this is getting added to small boards and this is getting added to small cells, as opposed to board row and row. Like it was hard to keep track of what goes with what. So now it's a little more clear that we're making an empty board and we're sticking it in that array, and we're creating a cell and sticking it in that array, and that seems fine. And maybe small cells actually is wrong. Okay, this is part of why, like, it's important to think about names. So it's a little, you'd think this is right. The small boards are contained in the big cells. So that kind of makes sense. So I'm again using rename symbol because it renames only the ones that actually Like, it's a little smarter than just find and replace, but we're making the cells and then we're putting the boards in them. And I would even organize this. So we make the cells, make the boards, and then we're gonna make the actual cell, put it in big cells, then make a board, put it in small boards. And there's a relation between the big cell and the small board that it contains. All right, and now inner cell, by contrast, is, oh, and that, I noticed that because I wanted to rename this variable cell, big cell. So now it's clear we're adding a big cell to the big cells array, and that's cool. And so then that means this inner cell is a small cell. And the small cell is the one that we actually click on. So now that fits with what we said up top. And then I think that might be all of the renaming. Let's just take another quick peek. Yeah, so now these names also help us see that, like, down here, we're appending the small cell to the big cell, which makes a lot of sense. And then we're appending the big cell to the board. So like this name used to be cell, and it just would be a little bit confusing of like what's getting appended to what. So now these names are helping us sort of keep everything straight. Okay, so now we need to look at the logic. So the run winner is this function that's basically from the old Tic Tac Toe game, and this seems fine. This takes a board is, like we said up here, a 3x3 array containing marks. So anytime you have one of those arrays, you can pass it into this run winner, and it is going to either return a mark if there is a winner or false if there is not. And since any mark and the mark is never going to be, it's going to be either X or O, those are true, or as JavaScript programmers would say, truthy. And so we can actually use them in if statements as they stand. And false is obviously false. So the only thing I don't like about this function is run winner sounds like it does something, like it executes a procedure and has some side effects. But actually, this is a function that answers the question. It was like, is there a winner, or returns the winner? So let's rename this is winner. And it sort of, that seems fine. Partly because I noticed there's a variable up here called winner. Actually, you know what? Let's rename this winning mark, because that's what it's going to be, because it actually comes from is winner. And then we'll just rename is winner winner. So it's the function that returns the winner or false if there is no winner. And that's a kind of common pattern. We could also use undefined, which is maybe even kind of better. It's like the winner is undefined. There's not a winner yet. It is also effective. Not return anything, and then we'd automatically get undefined. So either, however you want to do that. Okay, so now, and this I'm pretty confident actually works fine, so we'll just collapse that. There's this other function here that we'll come back to in a second, because I think we're going to have to change it. So let's make now a little to-do list of what happens when we click on one of these small cells. So first, so for the very first thing we need to do is like determine if we should do anything. Like if there's a bunch of things that would prevent us, like if we're clicking on a cell that's occupied, or if the whole game is completely over, or if we're constrained to move on a particular small board and the click is not in that small board, then we should just ignore it. So all right, so we're going to ignore the clicks otherwise. All right, assuming that we're not ignoring the click, what are we going to do is we're going to make a move on the small board in the click cell, right? And so we're assuming that like we can move there and the cell's not already occupied and whatnot. And then we're gonna check. So just you can think about what you would do if you were playing this game on paper. So you've made a move and now you're gonna say, hey, did I win that game, that small board? If so, there's some stuff that has to happen. So check if the small board has been won, and if so, make a move on the big board. If the big, or like if move made on the big board, check for a win or tie there. And checking for a tie is a little more complicated. It's like used to be we just count moves, and if we were on our 9th move and nobody's won, it's a tie. That's in simple tic tac toe. In this game, it's not quite as simple as I mean, I guess it's when all 9 of the positions in the big board have been filled, but we don't have it's not in a simple move count. It's not as simple as though I think down here there's something that checks for 81 moves, but it's actually that's not very likely because you might win some of the small boards with fewer than 9 moves, and then you'll never get to move 81. So we're gonna think about how we can check that later. So if a move is made on the big board, check for a win or a tie there, and possibly end the game. Announce the end of the game. And then if the game is still going on, determine what the next small board to move on is, if any. All right, so it's possible, according to the rules of the game, if I like, whose move is it? So like if O has won this top middle board, and then someone moves down here, this would ordinarily send us to this board, but because the board is over, you actually can't move there, not obligated to move there. And so now O would have a free move on any small board that isn't done. So there's a little bit of logic about, where the next move has to be. It might be on a particular small board, or sometimes it's a free, like at the beginning of the game, it's a free choice. So, okay. So that's kind of our to-do list. And now we can look at this code. And because this code isn't actually working, this is not a pure refactoring kind of situation where I'm just trying to make the code simpler but preserve its exact behavior. I know the behavior is not quite right. So this is a little bit like the last video where the Connect 4 winner checker was a little bit buggy, and we had to sort of simplify it to figure out what was wrong with it. So like we saw before, this doesn't actually correctly stop us from moving someplace. So there's obviously a bug in here somewhere. And then along the way, I'm just going to try and simplify things a little bit. Okay, so now we can compare our to-do list to what's actually here. So the first thing is everything in this on click, right, which goes from here down to here, is basically inside this if. So nothing happens if it's not a legal board and not winner, right? So if there's no winner on the inner board, which is the board we just made up here, and then assuming this is legal board is checking, like, is this a board we're allowed to move on? That seems like roughly correct. There's also this if game over, and if we said game over was the global is the whole game over, it almost feels like this should be up here as well, right? So to really determine whether we should do anything, we got to check all those things. So I'm going to actually move that up here. So if the game's not over and is legal board, I'm going to, so this function is a little funny because it's taking a cell and we can look at how it works. So it's doing something. It looks like what's going on here is that the next board is going to be not a board per our nomenclature that I made up. Obviously, I can't blame the person who wrote this for not using the nomenclature that I'm now using, but yeah, we're setting board to a cell. And so now we can see this is another, like this, these variable names show us what we're getting. So this is one of the big cells. So next board is either null or a big cell. And so it looks like an inner cell. If we follow our naming convention, we call that a small cell. All right, a small cell has a parent element. So this is a DOM thing where we can get like small cell is actually some div and it's inside some other div. And if that div is one of the big cells, then like it's the small cell that we actually clicked on is part of that bigger board. So that's a reasonable way to do it. I would suggest that we actually want to use our pure data, like our boards, as our main, the data that we're going to use in our logic, and use the DOM stuff just as the way to like put stuff on the screen and to handle clicks. So I'm going to switch things around and say that next board, like its name says, should be a board. It should be one of these arrays. So it's going to be one of the 9 small board arrays, which live in our small boards array, 2D array. Okay, so we can take this if statement out. Now, notice how we take if statements out. We find the closing brace, which the editor is highlighting for us down here, delete the closing brace, and then delete this line. And then we hit reformat, and everything should just shift over a little bit to the left because it's not inside that extra layer of if anymore. All right. And then this if is checking that the small cell is not empty. And so to make that a little simpler, I'm going to do one of my favorite things, which is make a new function, takes a board, a row, and a column. And this one is written, oh, this is also violating the rule I just suggested, which is we don't want to use the DOM elements and the inner text, because maybe later we're going to like change what HTML we actually use or put some extra elements to style things or who knows what. So we want to use our boards to tell whether things are empty or not. So instead of checking the small cell, we want to check the board. We want to check the board in the row and column of the thing we're clicking. And so to test whether something is empty in that context is actually pretty easy. We have the board, we get the mark at the row and the column, and it's empty if it's the empty mark, the empty string. And so now we can just add that to our expression up here. And inner board, and then R and C comes from these things. So inner board is a variable up here, which that reminds me should rename because it's a small board. Now everything matches. We push a small board into the small boards. Okay, so if there's no winner on this small board and that row and column is empty on that small board, and so we'd like this function to take the small board as well instead of this cell. Okay, but we can get rid of this now too, because that was just checking whether the cell was empty, and that was also blocking off pretty much everything, though this was somehow outside of that. So again, delete the closing brace, delete this if, reformat. And now we can also, we don't need this declared up here. We can move it down to where it's first used, which I think is right here, right? And we don't actually ever need it to be false because we're just going to set it so. And we don't ever change it, so we can make it const. So I'm just moving that code so there's this little gap between where we define it and where we use it, so we don't have to worry about it up here now. And that lets us now look at this code. So this is setting the text on the screen by setting the inner text in the cell, but somewhere we must be putting this mark into our board or everything is messed up. And we in fact see that. That's down here. So we can at least move that up here. And now we can even, yeah, I think that's fine. I guess I would make this a little more concise. I think I've shown this in a couple of videos. I would define a variable called mark and then use my friend the ternary operator to set the mark to either X or O. Oops. Which lets me flatten out this if, and then set both of these things to the mark. And this is a nice little chunk of code. Let's do this. I'm going to copy that, and I'm going to come down here and make a function called make move that's going to take a board and a cell and a row and a column, because those are the things that we're kind of using here. The cell is that, the board is that. Put them in the same order I mentioned them here. Increments the move, and just for grins we'll return the mark. So it's using the global move variable to determine that. What mark to make, and then it updates it, and then it returns the mark. And so now we can simplify this to make move small board, small cell, row column. And this is gray because we haven't used it yet for anything. But I think, actually, I don't know if we will even need to. Maybe that was premature. Okay, so if we need it, we can get it. But if we don't need it, we can just ignore it. Last move doesn't seem to be used at all. Okay, so this make move, hey, look at that. That's our item number 2 on our to-do list. Make move on the small board in the clicked cell. So it's updated the board, updated the text on the screen, updated our move count, and we're all good. Okay, now 3, check if the small board has been 1. The next bit of code here does not seem to be that. That seems to be about actually our 5th thing. So I'm going to move that down below somewhere. Well, I'm going to move it down to the very bottom here. That's our 5th thing. Number 5. And where's the code that is checking if the small board has been 1? That is basically this code, right? It's calling our function winner, passing in the small board, and then at the moment it just seems to be logging some stuff. So we get the winning mark if there's a winner. And if there's a winning mark, then we're console logging it. But this is not doing the thing, make a move on the big board. So this seems to be the first really big, like there doesn't seem to be anything that actually updates the big board. Right, we have big board up here, we can see, and it is in fact never really used. So now our to-do list has kind of shown us where we need to fill this out. So if we have 1, this is exactly the place that we need to update the big board. And so the big board, which position on the big board is it? It is the whatever big row and big column we are part of. Sorry, big R and big C, right? Because this small cell is all part of some it's the small board at big R and big C. So if it's like this board, it's row 0 of the big board and column 1. So it's at 0, 1. Big R is 0, big C is 1. And so that's the place we want to make the move and set the mark on that board to be the winning mark. And that's really the only way that moves get made on the big board. So it's actually somewhat simpler. We don't have to worry about checking whether it's empty because it's not just some random person clicking in bad places. This could only happen if we just won a game on a board, and the only way that could have just happened is no one's won before, and so this is definitely empty. Okay, and so that brings us, if we're here, that means we're actually in step 4. If a move is made on the board, check for a win or tie there, and possibly announce the end of the game. So now we got to turn around and say, if there's a winner on the big board, and we don't even really have to worry about who the winner was, because it's obviously the move that was just made. It's the same mark. It's actually the same mark that was made over here. What do we want to do? We want to possibly announce the end of the game. And in fact, there's code here. If we look in our HTML, there's a div down here, ID winner, where we can set. That looks like a div. I don't know what these are doing, but there's a div where we can put some stuff. And there's code down here that announces a tie. Not sure if that's announcing it in the right place, but if we got to here, we want to say winning mark wins. Oops, need to add those. And so if we didn't win on the small board, then none of this would happen. If we won on the small board, but it wasn't enough for to end the big board game, then I'm going to announce that. Now it is possible, the other thing that could happen, we said check for a win or a tie. So we want to somehow say else if is tie on the big, oops. Sometimes the autocomplete, if I haven't written this function yet, it will think I mean something else. So I hit escape there, and now I say is tie big board, and now I can go write that function. So let's assume that I have this function. Then that's when we actually want to announce the tie by the same mechanism. So if there's a winner on the big board, announce a win. If there's a tie, and then we'll worry in a second, like right now, how do we tell whether it is a tie? So like I said, in the old Tic Tac Toe game, we just counted the moves. But in this, we should be able to figure it out from the board. And we should be able to do this for any board, right? A board is just a 3x3 array of marks. And so the 9-move thing was basically saying if the board is full. Okay, so we can tell whether the board is full by just looping over all the rows and columns, which we definitely know how to do by now. Let C equals 0, C less than 3, C plus plus. And this is a kind of one of our loop patterns. This is an every loop, I guess, or yeah, if every element of the board is filled, then it's a tie, otherwise it's not. So that means if board RC, the mark on that position on the board, is empty, It's not a tie yet. We can return false. If we loop through all 9 squares and haven't found any empty squares, that means the board is full, and we can return true. And in fact, this function isn't really testing for a tie, because if you passed it a board that had 3 in a row on it, it would say it was a tie. So I'm going to, in the interest of being as accurate as possible, I'm going to just say is full. So that way, if I, later on make this code more complex or something, I don't want to confuse myself and think that this actually checks for ties. It just checks whether the board is full. And in this context, we can see we check first for a winner, and if there's not a winner, but the board is full, then obviously that's a tie. So that's like, names are important. It's important they be accurate, so we don't get confused about what's going on. Okay, so this little bit of logic here, like I mentioned, 81 moves is not really right, because the game can definitely be over before you've made 81 moves. But it does have this game over that gets set, which we didn't put in our to-do list, but yeah, we used it up here. So that means if the game is over, we need to record that fact. And so now we know when the game is over is obviously those 2 places. Okay. So that's gotten us through 4. 5 is now determined what the next small board is, if any. And we took this code out of this if statement, which seems like a good thing, because this was a little confused. This was like the global game over, but winning mark was really about like whether we won on the small board. So I think that was maybe the root of some of the confusion. This line of code is assigning the same click handler that's on the small cell to the query selector. It's also inside the click handler for the small cell. So the first time, this just seems like kind of nonsense. Apologies to whoever wrote this. I don't know what that was doing. Okay, so good. We got to delete some code. It's always nice when you find a line of code that you realize is not doing anything useful, because you can just delete it and your life is simpler. Okay, so now we're at our item 5 I'd marked before. If the game is not over, it doesn't really matter what we do if the game is over, but so we can just do this in all case. So this is where we were trying to use, remember this array back here, small game overs. So I think I actually suggested this array to this student, and so I apologize for that, because I think it's actually, there's an easier way to do it, which is now we've got these great functions like winner and is full and stuff that can tell us exactly whether a game is over. In fact, let's just write another function that takes a board and returns a Boolean that tells us whether that board is done. And that is very simple. It is full. All right, if the board is full, it's definitely done. Or winner. So it's not full, but there's a winner on the board. If either of those is true, it's done. Otherwise, it's not. And so now we can replace this array with a call to that function. However, there's a thing I got to point out here, and I think this is actually the bug. This check is not checking what this student probably thought, because this, hopefully you can see it now that I'm highlighting it, is an assignment. So this is assigning the value true to that element of that array. The value of this whole expression is whatever was assigned, so that is true. So this is just always setting next board to null. And we haven't really looked at is legal board, but we peeked at it, and if the next board is null, then any board is considered legal. which is kind of logical, but this is just always setting it to null. And so this, you might think the fix to this is to use the right operator, use the comparison operator. But then even better fix, even if we weren't getting rid of this array altogether, is just don't compare to true and false. This, like if we were using this, it's already a Boolean. The whole point is this array was going to hold a bunch of Booleans. So it's either false or it's true, and you don't need to compare it. If you're going to write this equals true, you might as well check it again and again. Like, when do you stop? It was true the first time. You don't need to keep checking it. So, and I'm not saying this to pick on this one of you who wrote this, because this is a very common mistake. And it's really important that you learn to think of Booleans, whether it's coming from an array or a variable or the return value of a function. It's answering a question, and you don't need to compare it to true or false. So the question we want to ask is the small board done? I'll delete that. If it is, oh, wait, is that not, that's not even the question. Actually, let's look back at what was here a second ago. So this is not asking about the current small board, like the board that we just moved on. This is asking about the board at the position in the big board where we just moved. We just moved it R and C. So if we just clicked here, that's row 0, column 2. That is talking about this board. And that's, if that board was over, then that means we're not obligated to, the next player isn't obligated to move there. And so next board should be null. So what we want is done the small board, right? That's our small boards are C, right? From our grid, our 3x3 grid of small boards that contains the actual boards arrays, we get the one for the current move. And if it is done, then next board is null. Otherwise, and now we finally get to fix this thing, we're going to set the next board to that same board, right? So if the board is done, next board is null, otherwise it's that. I actually, this may be just a little bit of personal style. I actually find it easier to read if we flip this and then flip these two lines. The next board, because the more common case is that, in fact, the next board is constrained. And then I might even go so far as to use the ternary operator again and say next board equals not is done small boards so this just one line sets the next board to basically this thing if it's not done, otherwise null. And okay, and so now the very last thing we got to touch is legal board, which used to take a cell and do this thing with the DOM that I said was maybe not a great idea. So we've changed it. So it's going to take a small board. And if the next board is null, right, so this is the function that we're calling way up here. Okay, so we're going to, now everything up here depends on the board or whether the game is over. So we're going to pass in a particular small board. And if the next board is null, then we can go anywhere. And the other possibility is the next board is not null, and it has to be, in fact, the small board that we passed in. Right, so we set it to some particular small board. So like if we had just played here, that means this small board, the array that represents that one, is going to be used as the next board. And so then wherever we click, it's going to be some particular small board. And if it's not that one, it should be ignored. So is legal board. Also, I'm going to rename that. I don't know what I mean, I know what this is doing, but it feels like what we're really asking is, can we move on this board? So rename that symbol. And so now our test up here is if the game's not over and we can move on the small board and it's not a winner and it's not empty. And actually now we can see this is actually even not quite right, because we also can't, well, it would get handled, I guess, if there's not a winner because it's a tie. It's only a tie if it's not full, but I think it's more clear to say maybe that's a little redundant because that's going to check is full when we don't really need to check it. But I think this is a little more clear. In fact, I might even be inclined to move this part of the logic into can move on, because that's really a function purely of the board. So can move on is true if one of these is true and the thing I just copied. So and maybe even best of both worlds. This is what used to be called is legal board. Still don't love that name, but I'm gonna put that there. So this is basically the function we had before, and then can move on is now just return is valid next board, and it's not done. So if it's valid and it's not done, and we need both because you might think, well, we never set the next board to a board that's done, but if we set next board to null, right, and we have a free choice, it still doesn't mean you can move here. So can move on depends on both. Okay, so if not the game over and we can move on that small board and the particular square we want to move on is empty, then we're good to go. Actually make the move, check the winner, and this chunk of code, I am also inclined, I'm going to copy it first. I'm going to put it down here below make move because it comes after it. Call this check winner, and this is a function that's not answering a question, but it's actually kind of doing stuff. And so now we just have to look at what variables it references. So it also operates on a small board. It needs to know what big R and big C that small board is in, so that we don't really need this console login anymore, but we need it to set the mark on that big board, and the winning mark we get from there. Game over is global, and so now we can come up here, check winner, small board, big R, big C, and now if we take out this to-do list, because we can basically put our to-do list right with the code that actually does it, and we can sort of see that we've boiled it down to almost one line per thing, or maybe 3 and 4. Are encapsulated in check winner. And 5 is that. Three and 4 we copied. All right, so now our whole on click is our to-do list. Determine if we can do anything. If so, make a move, check for a winner. If the move is made on the big board, check for a winner tie there and possibly announce the end of the game, which is actually happens down here. And then if the game is not over, determine what the next small board to move on is any. We're not actually, like, we could skip this if the game is over, but it doesn't really matter because once game over is set to be true, we're going to ignore all future clicks, so it doesn't really matter. So either way is fine. So I'm actually just going to delete these comments because I think this code is pretty clear now. And our click is pretty small board. All these variables are actually used. I guess we could do the same thing. That seems fine. Okay. So yeah, so now we've got this. Our big loop is still 25 lines long or something. Small game overs, I think we completely got rid of. I don't think that's used anywhere, so we can get that. And so if you look at what we've done, oh, and I guess I said I want all the functions at the top. So now I'm going to, this is really just code organization. So I have all these functions, and then I have the stuff that uses the functions. And I'm going to put that down here because this is where the code really begins. So all of the function definitions come first, including all these relatively little functions that we wrote along the way. Winner could be tightened up, but that's not the point of this video. And then we get into it. So after all our function definitions, now we use them. And this is where we declare our variables. We have the sort of mutable things, the move and the game over and the next board that are declared with let. We have our constants. Maybe I'll even put those up top. So we have the one big board, the two arrays of cells and boards, which could be combined if we wanted with objects, but it's not too complicated. And so now we can look at, like, the main code goes from 106 to 141, so less than 40 lines. Of course, I haven't tested this at all, so I have not been modeling the best behavior in terms of how to test, but cannot access mark. Okay, so yeah, never get away scot-free, but other good news, the code is pretty simple now. Line 28. Oh, whoops. That's just a typo. That should have been move. Okay, so now we should only be allowed to move in the center square. And we can go back to the center. Board is not defined. That looks like another typo. Should be big board. All right, that looks good. So here, 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 here. And our console logging about the win is still there. So that looks like that works. That also means So we just moved here. That means X should go here. Now X is going to move in the center square, which ordinarily would send us back to this board, but clicks here should be ignored because this board is done, but we should also be allowed to move wherever else we want. So maybe we can move here. And now we're back to X should have to go over here somewhere. And other things are ignored as is correct. So I think this is basically correct. The code is definitely simpler. And so I really want to emphasize what we did here. So the very first thing I did, I think, was make this list, which was just to get some nomenclature down, some consistent terms that we're going to use. So cells are obviously the divs in the page, and there's big cells and small cells. A board is always a 3x3 array, whether it's representing the big board or one of the small boards. And then I changed a bunch of names, I guess in code that's now down here, to I guess this is the only one that's not named properly because that's the board. I don't know what it is. It's the big, right? That's not an array. That's an element. So maybe we should call that something else. But it's only really used one place. In fact, we could get rid of that. But otherwise, the names tell us what they are. We use big and small in a consistent way, including even the fact that the big cells and the small boards sort of are parallel, even though because the cells are the big cells, but they contain the small boards. And then we have small boards and small cells somewhere down here. And we broke some things out. And then to functions, we gave them good names so that the code is kind of self-explanatory. And then the other thing after we got the name straight was just make a list of what needed to happen. Not in terms of code, but in terms of, okay, first we make the move on the page, and then we check if there's a winner. And then if there's a winner on the small board, we have to make a move on the big board. And if we make a move on the big board, we got to check for a winner there and ties and all the other things, which we listed out. And then we turned into relatively straightforward code that does those things. So I would say this is good. From here, there's some UI things we might want to do, and I think they'd be relatively straightforward to add, but I don't want to make this video any longer. But one thing we could do is at the point that we pick the next board, we could also highlight the corresponding big cell in some way. Actually, that's so easy. Let's just do it. So now I think I'm going to go back and make this back into a actual if statement. So, because we're going to do a couple things here. So if the small board is not done, that's when we're setting the next board to that small board. And then we're also going to, in the big cell, what I'm going to do, I'm going to manipulate the class list of, so this is like adding a CSS class. This is just next board equals null. And so what does that mean? That means we come over to here, and so this is the rule, the selector for the divs that are directly inside the board. So we're going to say if one of those divs has a highlight, we're going to make a border 3px red solid. Here, let's do aqua. And is this just going to work? What are the odds? Oops. Nope. I broke something. 132. Oh, whoops. Okay. See, and it highlighted that square. I just added like a line of CSS and basically a line of JavaScript. Now there's one problem with this. Why didn't it highlight that one? That wasn't the problem I was expecting. I think it's highlighting the wrong one. So, sorry, it's not the big cell. It is the big cells at the row and column, right, corresponding with this small board. So still one line, just the right line. So that one worked because I highlighted the same thing. Now it's highlighting that one, and the only problem is we didn't remove the old highlight. So the good news is, I think at the point that we're here, we just moved on a cell, and so that actually is the cell, big cell, like is the one that we're on, and we can and removing a class that's not there doesn't cause any problems as far as I know. So now when we move here, remove the highlight from here, and now I'm going to move in the center, which is going to make, would ordinarily make this the big board, or the next board rather, but it's not because we can't go there and nothing is highlighted, which means anything is open. And now we can come back here and go there and go there. So that's a pretty nice UI improvement. We could probably work on the CSS to make it look a little prettier, but that's kind of an example of once we get things straight and we're clear about what's what, and like this array is holding the cells and this array is holding the arrays, and then it's pretty easy to find the thing we need to change. Now you have to know this trick about adding a class and whatnot, but okay, so I'm going to call that good enough. I don't know how long this video is, but another one in the can, as they say in Hollywood.